Introducing our next guest. John is the co-founder and managing director of Enterprise Transformation Partners. He's been instrumental in bringing interoperability solutions to the resource sector. His team leads the UWA Energy Resource Digital Industrie 4.0 TestLab, or better known as ERDi, which established as part of the Australian Industrie 4.0 TestLab Network. This network plays a key role in the federal government's industry strategy and is supported through Australian and German collaboration. Under John's leadership, the ETP team has successfully designed and implemented the first Industrie 4.0 interoperable solution in both open pit and underground mining on a global scale. By working closely with multiple mining software vendors, they've helped enhance software production to support these critical standards. Today, John will be taking us underground, diving into the Industrie 4.0 technologies that are shaping our future of underground mining. With that, let's welcome John Kirkman to the stage.
Thanks a lot, and thanks for having me again, Datamine. I noticed a few familiar faces out there in the crowd. I was just wondering if I could get some hands up if anyone's seen one of these presentations I've given either at the Datamine forum or have visited the UWA Test Lab before and seen a presentation and demo. All right, no dramas, just gives me a bit of an indicator of how much context to sort of go in or skip to some of the other stuff. Appreciate it. I'll give you a bit of an overview. So the Australian Industrie 4.0 Test Lab was set up, the network was set up around 2019. It was from an initiative when Malcolm Turnbull was in place in 2016, where they signed an agreement with the German government to collaborate on the fourth industrial revolution, or Industry 4.0. So for those of you that haven't sort of heard about that, it's something that was born out of Germany around 2010, 2011. That phrase got sort of started to be used, but it was really about addressing a couple of challenges that German manufacturing had in front of them at the time. That was, mass production manufacturing, they do quite well, but when it comes to sort of meeting the bespoke sort of product requirements of customers and getting more like that was very challenging for them to be configurable and adaptable to the market. The other one was that they pretty much have three sort of core technologies that are sort of monolithic systems, if you like. You got your process control system, your MES system, and your ERP. And so they know there was a lot of advancement in technologies. You had cloud native and becoming a reality, enabling highly scalable software. They had, you got AI and other optimization techniques becoming into software packages, and they really couldn't implement these into their operations easily in these big sort of monolithic systems that, yes, supported a number of processes and talked amongst themselves, but when it comes to integrating new technologies, very difficult to integrate, new modular components into these sort of big architectures. We sort of have a look at mining. We're sort of at the other end of the scale. We're very modular. There's heaps of different specialist systems right across the business, but none of it's designed to integrate or talk with one another out of the box and in particular in any standard way. So essentially the Germans realised to get to the next evolution of productivity that the problem that could be solved through interoperability between a whole bunch of systems that allowed you to have a best-in-breed, plug-and-play configurability of systems, and started an initiative. And a bunch of different countries they recruited to get involved and help sort of close the gaps in some of these standards and also do the R&D to prove out this concept. And so they've been running a program. Their aim is to have it sort of finalised by 2030. And we've been sort of participating in the R&D adoption and showcasing of the various standards and capabilities that come out of the fourth industrial revolution. So there were 7 test labs set up in Australia at a university in each state. I think Victoria got a couple. And West Australia, the UWA Test Lab for Industry 4.0, and our focus is on energy and mining. So interoperability, obviously you can use it for a few different sort of areas quite well, but we're really talking about, when we're talking about it from the TestLab point of view, it's semantic interoperability between software applications, so common use of an information model and frameworks. So essentially we can exchange information out of the box. If I get a scheduling software package from vendor A, and I want to send it to a fleet management system from vendor B, I could use a common message to do that, and both systems will be able to, the receiving system will be able to understand that schedule when it comes through and use that data to automate workflows or provide insights to your users of those systems. So our area of focus, just because there's a whole bunch of standards around for different bits and pieces, we're really talking about information model and messaging standards, so we can automate information exchange between applications, bring things closer to real time rather than sort of cadence-based handovers. And we focus on a couple of core standards on the stack. So one is ISA 95 or IEC 62264. So it's an international standard for operations management. It says manufacturing operations management here, but essentially in mining, it covers your different levels of mine planning and scheduling, grade control modelling, drill and blast design and execution management, short interval control, fleet management, lab information management systems, materials tracking. Then when we get down to level 2, we're talking about a standard called OPCUA, which deals with the exchange between level 2. And a lot of this is covered under a new standard of standards that's been established, driven largely out of the energy industry, called Open Process Automation Standards. So one thing I sort of try to make sure is sort of understood is around these standards is ISO 95 is not really a technology standard. It's based on a common activity model that actually resides with any physical goods industry, be it manufacturing, mining, oil and gas, in contrast to a services industry, finance, legal and that type of thing. And so what they've done over years is defined a common activity model that sort of exists in each of these businesses, and an information model for each one of these activities and how information needs to flow into and out of each one of these activities, essentially trying to define it so if you have software supporting one of these activities, you could have all the information ever required as an input coming into it and all the outputs coming out of that software, and ideally completely automate the whole decision support and workflow within the boxes. So this standard was kicked off in 1995, and so there's been about 30 years or so of effort put into engineering this standard, and it supports any type of manufacturing. So it doesn't matter if it's pharmaceuticals or food and bev or discrete. This one standard is usable and applicable across that. Essentially, about 8 or 9 years ago, we had a look at the standard in a project that I was involved with to see how it would map to mining. What we identified is the activity model was near perfect for mining as well. But what we found was the information model was lacking. So, for instance, there's no way to express any spatial information in a message or in the information models. Operational locations, uncertainty on a measurement, these type of things were missing. We identified about 100 things that we thought needed to be added to the standard to make it not only support mining as it is today, but support future sort of ideas around systems and information that would want to be exchanged. And we worked with the standards group to make those updates and got those updated in 2019. And so that was the first point that we felt fairly comfortable that we could go to a software vendor and say, hey, build in this standard interface to publish a schedule or an actual or an actual around an updated inventory balance or a lab result, and be quite confident that not only could it handle anything and everything that they might have in their system as to do with that type of information, but probably in most cases a lot more information types than they were currently catering for in their software. obviously we didn't want to go to vendors and ask them to publish out grade control blocks if we couldn't handle spatial information and that type of stuff. So how does interoperability help improve mining productivity? That slide's a bit funny. Looks like some things have been cut off on it. So essentially what we've got here is I don't think it's showing up. We've got a short-term scheduling system, fleet management, materials tracking, and typically this is very generic, but typically there's a whole bunch of sort of manual data handling of information that feeds into a process. Poor old mine engineers everything's just manually entered into mine planning processes and checked and balanced and that side of things. Simple amount of time doing that compared to just running a schedule and looking at different options. Information's handed over to Cadence and organised agreed time of the day or week. And it's just significant opportunity loss because we don't have the best available data that is somewhere in the business in the systems that need it at the right time. So yeah, a lot of wasted time and effort for professionals. Obviously it's not really an attractive job, but probably don't know any better. And lost opportunity for the business in terms of, running things more optimally. So there's a few articles out around that, but sort of describes it here. Often when we do exchange information too, it's sort of very simplified. So you might be running schedules with the benefit of a haulage simulator and looking at all the resources and got your assumptions there about the different rates and all these type of things. But when that goes to a fleet controller, it's like a printout of the summary of the targets for the day. And so a lot of that information that could flow through into a execution management system that can have algorithms to help optimize against those targets and assumptions never makes it there. So the lack of interoperability is also holding back innovation in a bunch of the systems. Why would someone go and build all these advanced algorithms into their software at a cost when the data doesn't flow through and they know that their customers aren't going to be able to provide them with an architecture where this data flows through into their systems. So it's just not going to happen, and that's why we're progressing pretty slowly, I guess, in these advanced technologies. And so it's quite simple, sort of where we want to get to. We want to be able to send information triggered by events, an approved lot of grade control box or schedule. Every time a truck dumps or a excavator loads a truck, you could have a message punched out. Every time a stockpile balance is updated by quantity or a weighted average grade calculation or a lab result comes back, have that information flow through, not in these big batches of data that sits in a spreadsheet at the end of the shift and sent through for someone to enter at the end of the shift, which is happening at every single mine in the state, around the world, all the time. That's just the norm. And so when you get to this world and you can do it by standard messages, the other thing that enables you is a bit of a plug and play environment. So as a end user, integration, when you go to try and integrate things yourself in a bespoke manner, it's not cheap. You've got a bunch of technology people there trying to map data together that, is different and information models are different. If you do that once between two systems and then you change out the software, then you have to start again, because you're not doing anything to any particular standard. The standards are laid just to build it once and it's all done. So this is a bit of a view of a little subsection of it's like a demo that we do in the lab, but also this is a bit representative of a subsection or a subpart of the value chain for the first mine that implemented one of these architectures out of the box. So it was a bauxite mine in Guinea in West Africa, Guinea Alumina Corporation. So they essentially, we worked with a bunch of the vendors, so RPM, Wenco, the process control vendors, Siemens, Labs was Bureau Veritas, and Datamine with Mine Market, and all these systems. So all the vendors had their software engineers build in these new interfaces out of the box and some functionality around reliable distributed messaging to account for a few different failure modes across networks and those type of things. And then essentially all these systems work together out of the box. So schedules and grade control blocks get published out of your scheduling system where they're doing the reserving. That's received into your materials tracking system. and your fleet management system. Then they start mining against those blocks. Every movement's set up into your materials tracking system. The inventories are then updated about what's remaining in the block and what's on the stockpiles and their grades. Then as we go through the processing plant, we're basically modelling and tracking, simulating the movements through the plant and when samples are taken and registered. And then when results come back from the lab, they're automatically applied to those movements, which updates the resulting stockpile with those grades, and you can get those confidence factors and understand when you're looking at any stockpile post-crush, what its tonnes and grade is right now, and what is that made up of. Is that made up of 80% of the material and the grade information is from the block still, which has been rehandled through ROM stockpiles and crush, so probably not too accurate if you're trying to make a direct barge loading decision, or if I've got 80% of the lab results for that stockpile back from the lab now, and so I'm getting pretty confident that quality measure is quite accurate. So this was quite a successful project, and we have all these systems actually set up in the test lab, and we run a regular demo, so if you'd like to see that in action. None of the vendors spoke to one another. They just followed the spec that was given to them and tested, and then we hooked it up, and it all just sort of works out of the box, which is very nice. So underground mine. So after the first open pit mine, I was hoping to do a lot more open pits, but the next customer to come along from Goldfields took us out to Granny Smith, and they sort of wanted to have a look at what we're doing there. One of the challenges we had there is that there's a lot less software in place for some of the common processes. A lot of things were being done in spreadsheets. And so we went out and had a look. And so, basically the shift schedules are done in a spreadsheet, the 2-week plan's done in a spreadsheet, the shift schedules are just printed out, and given to everyone and sort of taken down the hole, and then people radio up in their actuals, which are captured in what they call a fleet management system, but more it's a sort of database for capturing your sort of physicals and actuals, and sort of obviously there's a lot of opportunity in sort of systemizing this and having information flow and getting real-time visibility in that space. But they've also got some real challenges obviously in underground with wireless data comms and network coverage, location tracking. You don't have the benefit of GPS, which is really, really nice compared to what we have to do underground. And the market's quite small, so the technology is a lot less mature than you find in open pit and other industries. So we had a bit more than just an integration interoperability problem here to deal with. We had to actually sort of help build out some of the core systems. And so when it come down to selecting partner vendors to work with on this project, a lot of it was about assessing the vendors' capability to develop these products, what their foundational technology looked like, before we could sort of get into the process of sort of building this stuff out. Where we've landed now is actually probably more sophisticated than the open pit implementation I mentioned before at Guinea. And a lot of that was because we're sort of building a lot more things from scratch, but also sort of dealing with the nature of rather than a schedule just covering, for one major process like a fleet management, material movement. We're dealing with the development, production, services, as well as the load and haul, all managed by different supervisors or controllers, if you like. So this project, which is at Goldfields Granny Smith project, and a lot of it's been commissioned, and the final commissionings are happening between now and June 30. We have a number of applications, all exchanging information via the standard messages. One of the really good things about this standard is it puts a lot of master data or metadata into the messages from a workflow perspective. So we're all familiar with plans versus actuals, but really it's just targets versus actuals. It's the aggregated amount of tonnes or drill meters per day versus the aggregated what did we get. No one really has the ability to understand task by task performance on start time, end time, assumed rates and whatever. Yeah, you can go and grab a team of people to go and investigate stuff and try and create that data after the fact. But with the way these standard messages and data is in these standards, that comes for free out of the box. Job IDs and concepts and versions are all embedded into the messaging. And straight away in real time, you can have that information and be understanding, is it a schedule quality issue that we've got here? Our assumptions around rates for different processes, different times, sort of all over the place, or is it an execution management maturity aspect? And have all these insights that are essentially, without purchasing another bit of software and just improving your processes, you can go and make those tweaks into this system and then have a look at the data again. So it really enforces quite a big capability for a plan, do, check, act cycle, where you can actually check properly and act and apply that back into your systems and have it all flowing. So this is sort of one aspect I just want to talk about, which is up here. One of the things with interoperability and sending data, but sharing data between systems, and I'm sure for a lot of you, a lot of that's probably relevant mostly at the moment, where you collect data from different source systems to push into some type of data store or data warehouse for your reporting. That's the sort of main place where people seem to bring data together, just about everywhere. One of the challenges we've ever been involved in that is, different software applications will call essentially the same thing, different things in their applications. And also, because those software applications are typically implemented and configured by different vendors with different stakeholders within your operation, often the exact same object or location or equipment in your business is called something different in each one of those systems. And so what that causes is a whole bunch of mapping needs to happen outside those systems for all your reporting. When we're going to integrate sort of, I guess, across the different systems, and these messages are coming out triggered by events in real time, we can't have this mapping logic in between. It really gets in the way of the reliability of the system. So we've got the standard messages, we've given it a standard structure, that's all good, but what about my configuration for my site? And so to handle the master data alignment, part of the architecture is having a master data management system where you're proactive about it. It's not after the fact, it's before the fact. And so this is where you define everything essentially, your data representation of your operations, all your locations, all your processes, what the schedule's going to call that process is the same thing that your fleet management system needs to refer to that process. That's all defined up here and then sent in a standard message. It's basically a configuration file for all the systems, and then each system, each vendor would need to be able to subscribe to that message and use that data to configure their system with that common representation of your value chain. That way, whenever we send a schedule, it's referencing all the same IDs and names as the system that's going to be used to execute it, as the system that you're going to use to track. And that's how you get that master data consistency across all your systems. So that was included in the standard because the standard is around automating this and optimizing across different processes. So that's one of the key things that you would have never come across before in mining in a business, is that sort of centralized before the fact configuration and management of master data. Typically, if there's anything about that, it's always after the fact to clean up things to a common data model into a data warehouse. So sounds similar, but pretty big difference in the approach and how you go about it and the benefits with such a thing. So this is the typical sort of demo we've got in the lab. So you're welcome to come down anytime. You just go on our website and get in contact with us. Usually demo and a sort of overview, which is a bit more detailed than what I've gone through today. It's usually a 90-minute sort of 2-hour session with Q&A in it. You come down and you can see all these systems working and a few scenarios, and we've got a simulator running as well. We're doing some work in the background to extend that this year, so hopefully by July we've got that sorted, and that's when we're going to introduce process implant simulator, open process automation, which is a very similar thing to what I've discussed about for operations management, but for the process control world. So this has really taken off in the US on the back of some work ExxonMobil's done. It's basically dropping the cost of a distributed control system in half and give a lot more flexibility, a lot more access to data. And so it's starting to really change the landscape in the process control world. We'll also have C-class Datamine limbs involved there. And then also, because we've got this sort of rich aligned data sets coming through with all this additional metadata that you just wouldn't have in a normal operation, we're going to be starting to work with the AWS guys who sponsor the lab and basically start to have a look at running some sort of AI solutions sort of over the top of these data sets, because they're all aligned and very rich and a lot of validation in there. So just sort of data sets that are really hard to get from any sort of operation when you don't have this type of, dare I say, plumbing around your whole systems. So when that's available, I'm sure we'll make some announcement, and you guys again are welcome to come down and have a look at that. And I'll probably, just to what we do at the test lab, we do standards research and development, interoperability proof of concepts. So we've had a few customers that were couldn't believe what they were seeing and just wanted to run a proof of concept before they sort of went to do something. So we help out with those. We'll showcase the technologies. So if any vendor actually builds compliant with the standards, we'll showcase that. We do conformance testing and education and enablement as well. So they're the type of services run out of the lab. And that's pretty much it.
Thanks, John. Thanks, Kirk.